In this video, we're going to discuss how to do product tie-in pricing in Excel using Solver. So the steps are, first, to figure out the demand curve based on historical reserve price and unit sales. And then after we have the demand curve, we're going to optimize the price to maximize the profit. And there are two calculations we're going to conduct. First, we look at if we just maximize the razor profit alone, what profits do we have from razors and blades in total, and what is the optimal price level. Second, we're going to set the optimal price by maximizing the total profit of razors and blades, and we'll see what that optimal price level is. So first, let's create the demand curve. So select the first two columns of razor price and the demand. Control Shift right and down, and then insert scatter plot. And let's enlarge this, and always label your chart: horizontal, vertical, and this is price, and this is demand, and then this is the demand curve. So in order to create the demand curve, right click on top of these dots in the scatter chart, and then add trend line, left click, and here select display equation on chart, and this is our demand curve. Let me enlarge this, easier to see. So let me type this down. The demand curve based on historical sales is demand equals, I'm going to put the intercept down first, 510.09 minus 20.535 times the price. So that's the demand curve. Now we have this demand curve. Let's copy this, Control C, and go to the new sheet where we're going to do the price optimization. So the demand curve generated from trend line is here. So I'm going to right click and just paste the value only. So now we have the demand curve here, and then based on the demand curve, we're going to start to lay out the calculation of the profit based on price. Additionally, we're given the information that the owner of a razor, generally speaking, buys 24 blades in the razor's lifetime, and the profit from selling a blade is 50 cents. So the variable cost per unit is already given. That's $5 per razor. So for now, we don't know the razor price, so we can put in any dollar value. Let's say we put in $6, because it has to be larger than the variable cost, otherwise it makes no sense. So $6. And the razor demand is equal to, using the demand curve, so let's type in 510.09 minus 20.535 times the price we have just put in here. Currently it's $6, and enter. So the demand is 387 units, and the razor profit is equal to, again record the equation, price minus the variable cost. Let me first type this down. Profit is equal to price minus variable cost times demand and minus fixed cost. And here we know that fixed cost has no influence on profit, so I didn't even give you the fixed cost, so we don't have to worry about it. Let's eliminate this because it's irrelevant. So the profit component without fixed cost is equal to the price of the razor minus the variable cost, and close the parenthesis, and times the demand of 387, and enter. So the blade, once we know the razor demand, we can figure out the blade profit as well, right? So this is equal to the blade's profit is 50 cents per blade, but for each razor we can sell 24 blades. So the demand of the razor here times 26 would be the demand of the blades. And since each blade has a profit margin of 50 cents, and multiply together, that gives us the profit from the blades. And the total profit is equal to the razor profit plus the blade profit, and enter. So first, let's price the razors based on maximizing the razor profit alone. So we are going to set the razor price in order to maximize the razor profit. We're going to look at the razor profit as well as the total profit when we do that. So to do this, we're going to use Solver. Go to Data, Solver, and set objective is the razor profit to maximize it. And by changing the variable cells of price, so that's here in C7. So now set constraints on the variables we want to change. We always need an upper constraint on price. So let's set a very large value so that it wouldn't influence our solution too much. So the constraint, let's say a razor cannot be over $50. That's reasonable. Click OK. And we can set a lower constraint. Since we already know the variable cost is $5, so it really cannot go below 5, otherwise we're not going to be in this business. So again, constrain the price to be larger than or equal to $5. Click OK. So now we have set the constraints on the price. Uncheck this because it's not necessary. And again, we're going to use the GRG nonlinear method. And there are options for this method. Going into the options, we don't need to change these parameters in general. And the maximum iteration time, again, I'd like to set it to be larger than the default. And then go to GRG nonlinear, check multi-start, and click OK, and click Solve. For Solver, this is a quite simple problem, so it solves usually instantly. It says it's converged to global solution, and click OK. Now we have that the razor price is set at about $15, and the profit from the razor is $2,021, and the total profit is $4,669. Pay attention to that number. We're going to come back to it. So now we have set the price based on razor profit maximization alone. What if we try to maximize the total profit? What happens? So next, let's do that. So in order to do that, I'm going to make a copy of the sheet that we have already done by right-click here and left-click on Move or Copy and check Create a Copy, and then move to End. So click OK. Now I'm going to create a duplicate sheet, and let me rename this Optimize Razors and Blades. And we're going to price razor based on the total profit from razors and blades. Okay, so much of these calculations we have done is the same. We still have the same variable cost, and the razor price we still don't know in this case, and we're going to solve that. And the razor demand is based on price. It's the same formula, so we don't need to do anything. The only difference here is instead of maximizing the razor profit, we are going to highlight this, maximize the total profit. Now let's go back to data and solver. And in solver, so now set objective, we're going to change the objective from C9, delete this, to the total profit in C11. We still want to set the razor price. It's just that we are maximizing a different profit, and the razor price range still is between 5 and 50. That's our constraint. Really, we don't need to change anything else. Now let me click on solve. Again, it's a simple problem for solvers. It's really fast, and the solver has converged in probability to a global solution. So click OK. Now we have a new solution. And remember that in earlier solution, we have about $15. And the total profit, let me copy this over. So actually, let me copy this whole thing over. And Control C. And go back here. Control V. Okay, so this is the old solution, and now look at the difference. So what happens is when you optimize the price to maximize the global profit of razors and blades, you actually would set the razor price much lower, and you sacrifice the razor profit, so it went from 2,000 to about 1,100, but you gain a lot more on the blade profit. So and then the end result is your total profit is actually quite a bit higher when you do this, comparing to setting your razor price to only maximize your razor profit. This is the whole idea of loss leader pricing, that razor here is kind of a loss leader, that you don't profit so much from razor because razor price is low. People are buying more razors, and as a result they buy a lot more blades as well, and the blade is really where you make the money back. So that concludes the video for product tie-in pricing.